My name is Steve Grasby with the Geological Survey of Canada.
Okay, so we just wanted to ask you a couple of questions. The first one we wanted to ask are, why are the Banff Hot Springs experiencing a cooling trend if they are?
Yeah, well, they're not really experiencing a cooling trend. It's more of, we see the same kind of average temperature every winter. But what's happened is that since the kind of drought years of around 2000 is that there's been a annual stoppage of the flow in the late winter. So that normally in the past the springs have flown all year round. And then in response to this drought that we see a decrease in flow. It varies from year to year, but it can be from November to January and an eventual stoppage, and then it won't flow for 1 or 2 months, and then it usually starts flowing again by May when we have the melt of the spring snowpack. So that's the main trends we've been seeing, rather than but the peak temperatures remain the same from year to year.
Okay. So what do you predict for the hot springs in regards to this cooling, I guess?
Yeah, it's I guess hard to make predictions, but I guess what we've learned is that they're very susceptible to variations in precipitation. So if you have a drought year or potentially more prolonged droughts that have been forecast by some climate models, that I guess we're concerned that it might impact the flow of the springs. And I guess to be clear, it's only currently the uppermost springs, upper hot spring and the kidney spring, which is just below it, that have seen a flow stoppage, whereas the ones lower on Sulphur Mountain, the Cave and Basin, haven't seen that same impact. But you do see a kind of a seasonal drop in temperature associated with that. But I guess so then, in terms of predictions, that if the climate models that would suggest more frequent and prolonged droughts are correct, then we'd certainly expect to see probably longer stoppages of flow through the winter, and potentially impact of flow stoppages of springs further down the mountainside, which will then be a concern for endangered animals that are associated with the spring waters, because they rely on the year-round flow of the water to survive. So if it stops, then it can be threatening those communities.
Okay, so what would you think makes the Banff Hot Springs unique to other thermal springs?
I guess one aspect is that they're sitting in the Rocky Mountains, which end just around Golden. So the Rocky Mountains are a narrow belt of mountains on the easternmost part of the Cordillera, which extends all the way to the west coast of British Columbia. So within that Rocky Mountain belt there's relatively few thermal springs, and partly because this very low heat flow area is not as hot as other parts of the mountains. So most thermal springs we see are associated with the west coast, where we have volcanoes and volcanic belts and much higher heat flow areas. So it's expected to see springs in those areas where you have a lot of heat. But where the Banff ones are, it's actually a very low heat flow area. That means that the waters have to circulate much deeper into the crust to heat up to get to the temperature that they are. So one thing we do know is that the waters from pretty much all the thermal springs we see in Canada are all originate as precipitation, so snowmelt or rainwater that are circulating down and getting heated and coming back to surface. So the lower the temperature in the crust, the deeper those waters have to go to get hot. So I guess that's what we wouldn't expect to see the springs in Banff, but that's why they're there is associated with some unusual geology and the fracture systems that are allowing this deep circulation of this surface water to get hot.
Okay, another question I wanted to ask was, what are the different formations of the hot springs other than the Banff?
Yeah, so in terms of how they're formed,
yeah,
it's partly related to the type of rocks that the waters flow through. So at Banff you see these large, what are called tufa mounds. That's what forms the Cave and Basin structure, and that's minerals precipitated out of the spring waters that grow that. And so that's kind of unique to Banff, or not unique, but it's unique to hot springs that are flowing through carbonate rocks. So you have to have the right rock type to form those type of structures. Banff is also well known for that rotten egg smell, the H2S gas you can smell there. and that's also derived from the rocks it's flowing through. So those same carbonate rocks have a lot of sulfur in them. There's bacteria in the waters that are taking that sulfur and producing this H2S gas, which you can smell. So the springs we see, say associated with volcanoes, we don't have those tufa mounds formed, and we don't have that sour, rotten egg smell, just because you don't have the right rocks to form the right minerals in the water to get that type of structure. So the geology of the area of Banff creates these different features and that you see associated with the springs that you don't see in other parts.
Okay, one more question I wanted to ask was, what is something unique you can tell us about the Banff Hot Springs that we wouldn't be able to come across on like internet research?
Yeah, so I mean, there's probably many unique features about it, or unusual features. One of the interesting things we found is that at the Cave and Basin site, which is formed by one of these tufa mounds, it looks like it started to grow around 5,000 years ago, and that's kind of an auspicious time. We know from multiple different records that there is a big change in the climate in Western Canada around that time, where we went from a much warmer and drier conditions than we currently see today to a more wet climate. So it suggests that the springs started flowing in response to this change of climate conditions, and it gets back to that earlier comment about how we see the springs are susceptible to periods of drought, and it suggests that, you know, these climate models are right, and we go back to these drier conditions that were more similar to 5,000 years ago, that we could see the springs potentially, you know, stop flowing altogether, because it looks like they didn't even start until then. So another interesting fallout of that is that if it's true that the springs started around 5,000 years ago, these some of the unique species we see associated with it, like the Banff Spring snails, it really implies that they evolved within the last 5,000 years to the onset of flow. So because they're endemic to the springs, they can't survive outside the spring waters, so they needed those springs to evolve to the current species they are, and they only had 5,000 years to do it. So we have done some DNA work, and it does suggest that was certainly possible, that could have occurred. So it's some pretty rapid evolution that we see going on there.